For those of you that don't know me, my name is Marsha Pierce. I'm the Database Solutions Architect at Pure Storage. And been a database admin for a long time, about 23 years, worked in lots of enterprise companies. My specialty is really kind of like CI/CD pipelines and virtualization. Did a lot of on-prem cloud solutions. And so when I saw like how containers were spinning out into SQL Server, while I was never able to do anything like that on-prem, right, as a data architect, it really was the dream, the goal for a lot of things that I was doing in my past experience. So I was very excited about this. So anyway, if you don't have your cell phones turned off, please turn them off. I just remembered to turn mine off. At the end of this session, you can go to passsummit.com and submit your evaluations. Or you can scan the QR code and submit your evaluations. Just so you know, there will be free 24 hours. How many of you guys have ever done the 24-hour line online pass events or anything like that? Nobody? So they have lots of like online events you can go to. There are SQL Saturdays all around. The first one is going to be in Nashville this year, which is every year in January. There's local user groups to get involved in. So volunteer. I went to my first Pass Summit session, I want to say about 5 years ago, when I was working for a large company. We had about 78 production DBAs. And when I started there, just for the SQL Server environment, which that's what happens when things are really bad. And I was brought in to clean stuff up, but I came here to actually meet the CAT team and recruit, and I had never been involved in the SQL Server community before that, and it changed my life. Not too long later, I started coming to Pure, started speaking at events, and I met all kinds of people. We were all first-timers. We said we were going to get involved, and I think most of us now either work for a vendor or Microsoft or are doing consulting now, and our local chapter leader. So you meet people here that you become really good friends with and that you have a lot in common with. So it's a good chance to meet good people and learn a lot of stuff. So this is my tagline. I have seen a lot of stuff and broken a lot of stuff. If you've been a DBA for a long time, I never break the same thing twice. People always ask me how I remember so many things. I'm like, I always remember something that's been broken because I never want to get bitten by it again. And how I ended up working for a storage company was that I drove the local storage admins up the wall. And the VMware admins, because I was always talking about performance. And so when Pure started up a healthcare org, I was recruited because I was a pain in the butt, and they thought maybe I could help like mitigate some of the concerns that when they had to deal with people like me. So that's how I ended up here at Pure. So it's going to be a quick overview at the first about containers, what they are, because I think a lot of people confuse some of the terminology. Then we're going to do some container basics so that you understand, and then we're going to get into the more fun stuff with container orchestration. So a little bit about containers. So if you think about where we've been in the world, you know, we started off in my career, we were doing these big data center implementations, right? Everybody's spending like probably months, half a month to a year, deploying all the servers, getting everything built. Wasn't very quick. You would do these huge waterfall projects. I remember hearing of projects that were like $20 million over budget and getting extended for years. And then the late 90s, early 2000s, VMware came out. And we started looking at virtualization because then we were going to be able to deploy things in weeks. And that was going to be super awesome. Of course, if you did a lot of virtualization, I still think a lot of people haven't done production virtualization all the way through for their very large databases, but we very early on virtualized all of our dev and test environments. And probably about starting 15 years ago, I started virtualizing really large, heavy OLTP workload databases in the north of 20 terabytes. And we got really good performance of them, but there was lots of consistency issues. Everything wasn't configured the same, so we started moving to on-prem cloud solutions using things like from Cisco UCS Director, vRealize Orchestrator, lots of scripting to kind of automate and standardize the deployments, right? Because how many of you guys have ever been bitten because there's one SQL Server configuration that's different? So I believed in kind of automating everything. I think your biggest box, whatever you do to standardize that, should be what everything is set to. So we just had scripts to like make sure that everything was deployed the same way, and then we had all kinds of scripts to monitor them to make sure that somebody didn't change something so that they didn't fall out of monitoring. And so that was a constant process. But then when you had to do those updates, it was very tedious. One of the things that I had done, I told you I worked in a shop with CI/CD pipelines, and we leveraged, I'll say we started out, when I got there, the servers were crashing probably 5 times a day. And that is not a joke. I thought, what the hell have I done when I got there, right? A recruiter actually called me on the Friday after my first week, and he said, have you realized you've made a mistake yet? And I was like, this is going to look really bad on my resume. I have to stay here. And so I stayed, and we fixed a lot of the issues, and we started implementing change control. And they were, they did a lot of trading on the stock market, and so they couldn't wait for like big projects. So I talked them into waiting, at least just doing it. At first, it was like twice a week. And then we got to once a week large deployments, and we were deploying probably about 250 database changes a week. We were rewriting a legacy app that was vendor-based to an internal-based app that they actually still have today. And they've grown when I worked there from like the 60th largest bank. I think they're now number 3 or 2. And I was talking to them actually about containers recently, because what we did was we built many different environments. We had several different dev environments. We had a beginning dev, we had a merge dev, we had several layers of QA, and then we had a UAT environment. And we started leveraging cloning technology for databases, because what they had left out of that was cloning the databases into the code, so developers would push code that worked really well for empty data sets, but not very well for really large, big databases. So when we started leveraging cloning of databases, so our UAT environment actually got from when we had everything in Subversion, we were using Jira at the time and some other tools. I don't think Jenkins was quite out yet at that point, and we had looked at lots of things. And before every code push, our last environment got a refresh from production, because, I'm just going to say how I say it, people suck and they bypass the change control processes. And if you're trying to always push forward, there's always somebody who has not followed the process, or there's been a break fix that somebody's forgotten to check in, and you need to pull data back. And even if you do have a perfect process, there are data discrepancies that are happening. Data's growing. You could have a bad feed from somebody coming in that's also going to cause you issues. So I think pulling data back is really important. But the one thing that they were really wanting me to get to, and we looked at all different kinds of ways of doing it, was getting every developer their own copy of the data set. And we had talked about like making the environments much smaller, but when you have as many changes as we do, it was very complicated to like keep that many. You know, we had 50 plus developers constantly pushing just in the Java development, and I had 20 DBA developers, right? So all those changes, it was hard to give everybody their own environment. And when some container orchestration tools came out and different things, I told some people to go talk to them about that, and they are now a really large customer of ours doing a lot of container orchestration. And they do the containers. I work for a storage company. They're leveraging us to help do that, but they implemented the container orchestration on their own. And so I think that's kind of very interesting what they're doing. And they do about 16,000 deployments of containers a day. They make 16,000 storage requests for volumes to deploy containers a day, but it keeps their code quality up. So that is where I think people are going right now. And then of course we've got microservices, which are containers that spin up really quickly and then spin down. We'll get a little bit more to that. But what are containers, right? How many of you guys have started looking at that? How many of you guys have containers in your environment, right? What are you guys doing with them?
Nothing right now, we're just playing with it, the same scenario. To provide VMs, containers, to all the developers, and with fresh data.
Yeah.
And the fresh data that we're providing right now using Pure is 15 minutes to maybe 5 minutes behind, with a database that's about 3 terabytes in size, and they get to play with that.
Oh, yeah, and it makes a difference in your code quality, doesn't it? What are you guys doing?
Same thing.
Same thing? So, you know, spinning up VMs, what I've seen when you start looking at containers, because you have the guest OS right underneath, I don't think really most of us care about the guest OS. We're really concerned about the application, as long as they're kind of all deployed the same. For the most part, when it comes to dev environments, as they stand up, and that takes even when you have dev environments. Like, have you ever tried to come up with a patching or maintenance window for a dev environment, right? The developers, that all has to be done after hours. They'll lose their mind, like it's the end of the world if you interrupt their development time. So what I have seen with some customers who have started to look at containerization for their development environments, because they're getting rid of that whole guest OS layer, they're getting really good consolidation where maybe they could get maybe 5 servers on a VM for SQL Server. They're able to get at least 25. My little ESX host that I've got, our former ESX host that we like reformatted, that is now serving up containers, says it can do 130 of them. And so you can get really good consolidation for those environments because you're not going to be running, at this point, really heavy workloads. But that's what I'm going to play around with next with those. And so you get rid of the whole hypervisor issue that you have. They've got their assigned amount of memory and RAM. They're sitting on a server, and they can be deployed really quickly, right? So you're getting rid of tying your application to the underlying infrastructure when you use containers because they can move around. If you ever try to boot a container, you know that it boots in seconds rather than, if you want to see, one of my actually containers is running on a VM in Azure and something broke it, and I'll show you in a minute, and I kept having to wait while I was trying to fix it 30 minutes for the VM to reboot every time. So you get out of that long haul reboot, like especially developers, right? Because they're pushing changes. They break something, they've got to rebuild their environment once they break it because a broken environment isn't anything good to test with, right? And then you get to modernize your existing apps. And why is that important for SQL Server when you look at containers? Because when containers came out, really people were talking about it for dev and web-based apps. They weren't really considering databases in there. But when you look at the fact that big data clusters, Microsoft just released that, right? Just made that announcement. That leverages poly-based containers. If you're going to run big data clusters, you're going to be required to run containers. There's no way around it. And I keep seeing Microsoft push containers more and more because I think that gets them decoupled away from the underlying OS, right? When you look what they've done with the PAL, product abstraction layer that they have for SQL Server on Windows and Linux, that kind of plays into that idea that they're trying to get away from being tied to the underlying OS. And then when you think about CI/CD pipelines like we talked about, containers play really well into that environment, getting everybody to that kind of nirvana state that they've always wanted to be with. And then the other thing I think containers play really well with, and I've seen some customers do, how many of you guys have heard about hybrid cloud, right? A couple years ago, we were talking about, are we going to go on the cloud? Or are we going to be in the on-premise? And I don't think that's a question anymore. It's what are we going to put in the cloud and what is going to stay on-premise? It's a little bit of mixture of both, right? A lot of people are putting their ancillary apps into the cloud, and they're keeping their core systems on-prem that are key to their business, that is their unique data, right? They're not worried so much about their exchange. They don't want that on-prem. They don't want to manage that. But their production systems, they usually want on-prem. Sometimes they go to the cloud, but they also want portability because they don't want to be locked in to a cloud vendor. I've heard of companies going up into the cloud, right? And then having to come back down. Or I've heard of people deploying dev apps in the cloud and then trying to bring them on-premise, and they don't work so well. So containerization gives you really good portability between on-premise and the cloud. And it even gives you good portability between clouds. Because what if your cloud vendor becomes your competitor? I've seen a lot of that, right? So there are a lot of healthcare companies who have been on AWS for certain applications for years, and they're now leaving because Amazon is getting into the healthcare business. There are certain grocery chains that will not go into AWS either that were there because they're now seeing them compete for them in the grocery chain. So this gives you portability at the containerization layer when you can easily move your apps because they can run anywhere. So hybrid cloud. And I had to put this in here because I think Bob Ward does a way better job of explaining how the containers look. So if you want to take a look at that, he shows really that, when they were coming out, persistent storage is really key to a good container deployment when you talk about databases. Application servers, somewhat, right? You still want to be able to keep those configs around, but for your databases, you want to have that still good persistent storage layer that's going to replicate your data around wherever your containers are going to be. But yeah, I like his little slide on that. And if you want to look at who's doing some really good talks on containers, I think Bob Ward is great on containers. How many of you guys have, who are into containers, have you read DBA Mastery or DBA from the Cold? Those guys do some really good blogging on containers. But if you're going to be a database person, right, and we'll cover this in a second when we start looking at basic containers, you've got to really be worried about the storage layer underneath. You've got to have persistent storage because, one, when you spin that container down, if you don't have a persistent storage sitting outside of that, that container data is going to go away. The other thing is that if you can spin up, when they were first doing demos of containers and they were showing people spinning them up really quickly, I was like, that's great. Now, how do you get your data in there? And they're like, restore it. I'm like, that's one, if you've ever tried to actually do a database restore into a container, it is not just a regular database restore command. You have to do, have you run the database restore commands? You have to do some importing, curl to get in there, and then run from the Linux prompt a command. And it's not very good at troubleshooting if something is wrong in your syntax, because you don't have any little query analyzer to tell you you've got an extra space and it doesn't like you. So, and then the other thing is when you start looking at these people who are spinning up containers, right, they're spinning them up because they're light and they want lots of them. So if you think about the fact that you've got a 5 terabyte database, what happens if you give 50 developers a copy of the 5 terabyte database? You don't want that on just direct attached storage. You want to leverage something that I would say almost every storage vendor has out there, which is the ability to clone data. So they all have that ability to clone data, and so you can leverage their technology to give you a really lightweight storage layer that matches that container, right? So we've got some customers who are doing that, and when you look at some of these container orchestrators, what you're basically doing, if you think about it, in the VM world, where maybe you give somebody a data store, it's almost like giving somebody a data store that you wrap the wheels around and you say, this, container orchestrator gets 10 terabytes, and you can import volumes in there that they can make copies of and stuff like that. So working with a good container orchestration software that's going to, for your storage is probably pretty important if you're going to be spinning up lots and lots of database containers, unless you want to wait for them to restore, or you want to put empty data sets in them, which is not what I want to do with containers, but there are use cases for everything. So this is the basic command for spinning up a container, right? And we'll go with some of the other commands, but this is, in general, you can spin it up without any of these commands and you'll get a really interesting name. You'll have to go figure out what the port number is, and good luck on figuring out what your SA password is. But that is the basic command for spinning up a container. And I think, oh yeah. So if you look at part of these commands, what are you doing in those commands? The -D tells you that it's running as a background service so that it doesn't go away as you exit the session, so that it keeps running. If you ever wondered why that's in there. You've got the port numbers. If you're going to play with containers, I really suggest that you try to play with containers on Linux, because you get into, how many of you guys are doing containers on Windows? Have you had the interesting issues with the port numbers? Yeah. There are lots of things that don't seem to work quite as well when you're doing the containers, so you can get port binding issues and things like that when you're doing them on Linux. I used to work on Linux when I was an Oracle DBA earlier on in my career, but I haven't touched it in a while, so I've been a little rusty. So you'll see a demo of me in a minute, like installing Docker and a orchestrator in a second. I did speed it up, but you can watch my little flubs in typing, but it's not that hard. It does get more difficult as you do other things, and we'll talk about that. So you want to get your port number. The first part of the port number is the machine or the cluster's port number, and the second half of that port number is what is going to be persisted to the container. And then you want to give it a name, because they do have very interesting names like Matilda Rocks, or something like that if you don't give it a name. So you give it a name, and hopefully when you have the container orchestrators actually on top of it as well, the developers are going to be using the names and not the port numbers, because they're going to be DNS internal to that container orchestrator, so that they're always connecting to the same name. And then all these -E options, and I put up here the whole list of different environmental variables that they are listed. There's lots of different options for installing, and they all start with the -E, but the basic one we have in this demo right now, for now, and it'll get more as we go along, is accepting the EULA and putting in our SA password. All right. So I'm not going to do the video because I think I did all kinds of videos in case something didn't work, except for the one I really wanted to do this afternoon. That's not working, but whatever. But I'll show you what it was supposed to do. So a basic container, right? What you're going to do is just run the Docker pull to get your command. And this is in my way. Right? So let's run this. We'll just run the whole thing. We'll run the Docker pull, and then we'll run the installing SQL Server container. Pretty easy, right? And if I go over here, where is my registered servers? I should have, or did I have it over here? Sorry, I had it over here. I've got SQL 01, and you can see in here, oh no, I'm on the wrong one. Let's go back to my window. It was, what machine am I on? Let me get my IP address. 12 and 13. Sorry, thought I had these all up so that I could automatically connect to them. And that is not the one I want. So we will just do this from here. Let me go copy my essay password. I'm the world's worst typer. And I lost my window. I was like, yeah. I was like, what's going on? 12. There we go. So here we have an empty database. So what we were going to show you, or I was going to show you, is what happens when I create a little test database, right? And is it really there? It's going to be down in the container in there. So there's my little test database, right? And I can create some table value data in here, right? Just going to do that. Connection. So let's create a little test table in here. Sorry. We'll just create another database. And then we're going to put some data in here, right? When I go down here and I look at my little FT demo database that I've got going on here, you can see that I've got the table and I've got all the data in there, right? And I can go in here and I can stop this container. And when I start the container back up, the data will be in there. Not that. But that is stored locally within the container. So when I go in here and I refresh it, after I stopped and started the container, the data is... Oh, did I stop it twice? Well, I did.
Making sure we're paying attention.
So when we go back here and look, I can run my select data again, and my data is still there. But what happens if I redeploy that container, right? When I redeploy this container and run this last one, You know what you have to do? You have to remove the container. You know, you wouldn't believe that I ran through this like a dozen times. I've stopped and started more SQL containers in the last month. And then if I want to see what else I have on here, I can look and see that I don't have any other containers running on this one. When we get to the other one, you'll see a lot more containers running on it. So no more containers. I can redeploy this one. But when I come back into my container and I take a look, there's no data, right? I've lost all my databases. And if I had them, I'll be really upset. But yes, all my data is gone. So that's why you want to persist your data if you're planning on doing anything that you want to keep outside of that environment, right? So let's see what happens when you persist data outside the environment. I think I've got a slide showing you a little bit more detail so you can see what. How many windows can you have open? So you can see. Oh, it's because it looked like that. So this is the command for attaching a database. The first part of it, I've got two parts of it. I have a really large database, so there are lots of data files. So you just give it attach DBS, right? And think about this. This is going to be scripted out, usually sitting in some kind of orchestrator. So you just have to create it once, and everybody's going to be using it. So it's just a kind of a pain the first time when you're doing this. But you've got the little equal sign here, and then you give it a DB name, right? And then I've got all my different files that I have in here. I've got a log file in here somewhere. Yeah, there it is. Tons of them. And then if I wanted more, I put a little comma here, and then another kind of DB name as well, because I had several database names going. So you declare that first before you run your Docker run statement. And then the other thing that you do in your Docker run statement right here was that I mounted a drive that I have locally attached that I can see somewhere. And I'm sharing that under the shared data. You can't attach it as any drive name. It has to go under kind of that root container, so it's going under the shared data folder. And then I run this attach command so that my database is actually attached. I could just go in, run the shared volume, and then go manually attach the database. Have a database script that runs afterwards in a job, but I liked it this way. So run the attach statement. So let's go take a look at what that looks like. And let's go back and remember to, look, stop. And the other thing I'm going to do before I do that, I'm going to remember to do this, is that I am going to copy data over into that volume that I've been using really quickly. So I just copied some data over to that volume, and now I'm going to mount my container with the volume. All right. So let's go back here and look and do a refresh. And now we have the FT demo database, right? And I wanted to show you how big this database is, how long it took. So we just put a 3.2 terabyte database really quickly into our container that our developers can use. And then I can do things like this. Let's go back and change our connection. I'm going to create the table guinea pig. Then I'm going to, did I put some data in there? I did. We can go back in here, see that we've got that. So now when we get rid of our container, let's go back and do that. Oh, stop. It's too early in the morning for me. I'm not a morning person. All right. So I'm not going to refresh my storage with that clone that I just put over it. I'm just going to recreate the database with the volume that was there. And when you go back in here and we do this refresh, you'll see that the FT demo database is still there. And what we also should have is our guinea pig table that our developer was working on with all the data. Still there for them to use. So that's where the difference comes in with the container orchestration. And you can script these out, right? I just scripted out one, was typing part of it in, but you can script them out and it can spin up 50, just a few seconds longer. Yes? No, I have one database. What I have, so what we're leveraging behind the scenes is called storage-based cloning. It's been around for like 20 years. But up until recently, it was historically very expensive for most people to use. So what I did, and I'll go show you what I did on the backside, was I ran this script right here. I just created some credentials. I connected to a server, right? I took that volume offline, and what I did was I connected to my storage device and made a copy of it. Snapshots at the storage layer work very differently than database snapshots or VMware snapshots. So they allow you to clone and copy all that data and push all of that copy management off to the array. And so I just made a copy. So now I have two 3.2 terabyte volumes. But because most arrays do data reduction these days, on our array, it actually consumes no extra space. It will only be when I start writing some data that's in one that's not in the other, when it's going to start consuming space. And everybody works on... That would be a little bit of space, right. But if I wrote the same thing to all of my databases, then it would just be have written once. And so it depends on, everybody works a little bit differently, but a lot of people get pretty good data reduction these days. And so the more you do this, the more your data reduction goes up, right? You would actually probably be consuming less space than you were giving your developers their own environments as you are today, doing the backup, restores, and copies, and they just come out in a few seconds, right? So we're leveraging the cloning technology on there. And so then you can create master copies when you import these in. What I would probably do is take some production data somewhere, run an obfuscation process, and pull that into my container orchestration as my gold copy, right? So all the developers that week will be refreshed from that one copy of data, and then I'll probably go do it again next week. We didn't usually grant, you can do full copies of them without obfuscating data, but we just did, because I always had PCI and HIPAA data. We didn't do that unless it was in something like the UAT environment, which is why we refreshed it before every code push, because it was locked down just like production. If you didn't have production access, you didn't have access to that environment. But yeah, I mean, think about all the, have you guys ever been asked to create synthetic data sets or come up with a process to remove data? This is so much easier to do that. Yeah. Especially if you have a high change rate. All right, so which one's this one? So that was creating not that one. So, and I've had this in there for a long, so these were some of the kind of what I based some of my stuff off of that I ran. So you can also start the SQL Server agent. I think 2017 forward, you can start the SQL Server agent in there. You can turn on always on availability groups. So some people are actually starting to look at these for production for not so critical data coming in, right? Where they're just trying to get some streams coming in to feed other systems. Yeah.
So you mentioned that this data copy was usually hard to access because it was expensive. So how do you actually enable it in your environment rather than Microservices?
Wait, okay, how do I enable what?
The data copy that you did.
Oh, so how would I enable that? So you would have to work with your storage team to do that, no matter what environment you're in, because that was a storage-based snapshot. But it depends on what you're doing. So if you're in a container orchestration, and we have lots of people who do this in our environments, and I did it, I mean, I've done it for 20 years. I've leveraged some kind of storage cloning in most of my jobs. But now with the container orchestrations, as you can import that data into there, and then let them usually kind of clone from within those orchestration utilities, you kind of granted them that access there, and you've segmented off a lot of the concerns that most typical storage admins have when you go into some of those orchestration utilities. Does that make sense? Because when you go into the orchestration utility, they usually have a plugin to a storage provider. It's called now the CSI plugin. We have a CSI plugin, plus we have what's called the Pure Service Orchestrator. Other people have their orchestrators as well. And if you're in something like, and we'll get into it in a second, like Docker or Swarm or Rancher, you integrate with that plugin, and then you assign volumes to that. It works just like a data store to that container orchestrator, and you say it's either block storage or it's file storage, and then it acts just like a cloud service that makes API calls, and you don't worry about it so much on the back end. Does that make sense?
Well, my question was more of like that data copy command that he had. It was really fast. Part of Docker is that part
No, that was actually that was a storage-based command that I made on my storage array. But you can integrate those into Docker, and I'll show you how people are doing it in a second into Ansible. So that's just another kind of PowerShell script that I would be running. Or you can run it in a YAML file. We have people running them in YAML files. So you just integrate that as part of your scripting, if that makes sense.
we write that PowerShell command, or is that
So that was a vendor-specific PowerShell command.
that's what I was going. What vendor were you using?
I work for Pure Storage, so that's what I have in my lab. So that's how I do it. But other people have their own commands as well. So I don't want you to think of this is like we're the only ones that do it. Everybody has their way of doing it and scripting it out. So whoever you're on, go ask them how they do it, right? People have different commands for doing this. Because believe me, I've leveraged them for a long time, and I've looked at customers who are converting and looked at their scripts. Everybody has a way of cloning those volumes out from the storage layer. They don't always tell DBAs about it, which I have no idea why, because we are the ones moving all the data around, and they don't realize how much data we're moving around. I was fortunate enough that I was always privy to that in my job. But yes, everybody's got it. If you're NetApp, if you're Dell, if you're a Compellent who's been around, I mean, trying to name everybody off. Everybody's got that kind of like copy process on the back end. Nimble, right? They all have something that you can do just like that. And more people, so it used to be like, I mean, super expensive, but like years ago when I worked for a large enterprise company, just for my project, I paid $25 million to be able to snapshot my databases to do what I just did there, and it wasn't as easy. But we had large multi-terabyte databases, and that was what you had to do to ensure that we could get them back up and running quickly in a data disaster kind of scenario, because we couldn't wait the 10 hours it was going to take to restore, the data in that kind of event. So we were leveraging this, but now as the software is evolving, most people are including them, and they're a lot more simple to use. And so they've been around for a long time, so I think because they just were so historic, a lot of times storage admins are running them on the back end and you don't even know they're doing it. And they're doing it to protect their own whatever in case something happens. So you just need to talk to whoever you're working with, and they can show you how to do that. But yes, it takes a lot of downtime off of what you guys are doing, right? If you think about all the ways we copy data around, CI/CD pipelines is one of them. But I'm trying to think, seeding replication, log shipping, seeding AGs, right? DR, all those things we do, ETL, data warehousing, reporting, all of those things are like ways we move data around that we can move it much faster. So, what was that? Oh. I don't know what, I didn't put a name in front of this demo. Apparently I recorded one and I don't know what it is. Oh, this is one where I'm doing kind of the same thing. And I'll show you this. This is the one, I have this later that's kind of broken. It shows me doing the same thing, replicating a container between two different environments and spinning it up in just a few seconds. And this kind of goes into detail here with the same thing of what I was doing. And you can even do it between the clouds. So lots of people, believe it or not, now storage vendors aren't just on-prem. They can run in the cloud. So NetApp, IBM, Pure, they all have the ability to run their storage in AWS, Azure. So you can do the same thing I did if you're on-prem and in Azure, and I'll show you that in a minute. You can replicate the data up between the two environments. So that let's say you have a production environment on-premise, you can then replicate it up to Azure and do the same thing and kind of snapshot your data into there and keep your dev stuff going. So this is showing kind of like what it looks like mounting a drive again. I think I just showed that one, so we'll skip that one. So terminology a little bit, and we'll get into some more terminology. I should have updated this a little bit. So the container host, right, that is what we were just logging into, that .12 server. The engine is what you're gonna, we run engine. Our engine is Docker, right? That's what everybody's running. And then and I'll show you some slides in a second on the other ones. The repository is gonna be the list of images that you have locally. And then the container images are the ones that are in a reusable state. So I hear a lot of people say, we haven't decided whether we're doing Docker or Kubernetes, and there's a lot of confusion over that. Everybody's running Docker. Usually when people are saying Docker or Kubernetes, they're talking about, am I gonna do Docker, Kubernetes or Docker Swarm? But there are other ones that are out there. Rancher is what I'm gonna be doing my demo with today. It actually runs Kubernetes under the covers. So it is an orchestration that runs a Kubernetes cluster underneath. And then there's Mesos OpenShift, right? So a lot of people who have to have certain types of support are looking at OpenShift. And then if you want to do a Windows-based container, there's Windocs down there. But there's tons and tons of them out there, of these container orchestrations. And what do container orchestrations do? Think of them really as your clustering and almost vMotioning capability. That's all they do. Because I thought they were going to be a lot more awesome when I started looking at them. I was like, now how do I automate all this stuff? They're like, that's not what they do. They just automate the movement of your containers around and load balancing the workload of your containers and making sure that you don't overload a particular server. And you can set anti-affinity rules like you can in VMware on the container orchestrators and pin people to certain servers. But that is what they do. The other thing that I think what most people, there's application managers, right? So if you've ever read some of people's blogs, Keel's one that a lot of people are using. So if they want to take their own image, right, and update it, so now you've got your SQL Server image, but I know that if I was gonna actually be deploying that in my environment, that I'm gonna take something and modify it so that it actually has all my default server settings that we have in our environment, so you wanna create your own image. So a lot of people will use something like Keel or ARM or Amazon Machine. And then application orchestration. This is where everybody wants to get to. That is what is gonna actually orchestrate spinning up the containers, not just load balancing them, and then doing all the other things, maybe running your some smoke test or something against the database as it comes up, deploy the code that the developers are testing to that as well. So this is what it took for me to install Rancher. The first thing you've got to do when you install Rancher is, let's make sure it's playing. Nope. And I sped this up, so you didn't have to wait because it was going to take like, when I cut out all the me waiting, like stepping away for that, it was like 10 minutes, and I figured you guys didn't want to watch a Rancher install for 10 minutes, so it takes about 4 minutes to run. So the first part of this is installing the Docker, right? So we've got the Docker Community Edition running. And by the way, the Rancher install was pretty easy. I'd never installed Rancher, and I got it right the first time. So if you're going to play around with one, I highly recommend it. I was told I work with a bunch of guys who do a whole lot of containers who wouldn't let me have access to the lab, so I had to build my own. I thought I was going to be able to use their lab. They said, use Rancher. I don't know if that's what I would go to production with. There's lots of tools out there. I'd take a look at them. And the other cool thing about the containers is that it's really kind of like mix and match. You're not stuck with like one product line, like, right? If you want to use, Jenkins versus, why am I blanking? Ansible, it doesn't really matter. There's all kinds of different monitoring tools. You can pick your own monitoring. You can pick your own code deployments. It's pretty easy. It's actually it's easy to like tweak what you want, but then it's a lot to keep up with, like who's the best now and how are they all different. Lots of research. All right, so now we got that running, and I just installed Rancher. And so this is me logging in for the first time to a web page to set Rancher up once I've got it configured. And I did a very basic Rancher install. It gets a lot more complicated, and I'll walk you through what Rancher looks like when you're doing it. So this is like, if I had something, I could kind of do an import, right? and kind of create that cluster, but I'm going to add this is not the cluster. I deleted this one. I ended up creating, oh, here we go, a Sql Server Cluster. Kind of left it all default. And I'll show you what it looks like in just a second. And this is the other cool thing. If you see down here, I'm doing custom because I'm doing on-prem, but you could connect different nodes and different things up. Your Rancher can control your orchestration between not just on-prem, right? If you want part of it up in Amazon, if you want part of it up in Azure, it can set that up for you. So that's what these container orchestration engines do. So right now, as you can see, I got to pick, you have to have the etcd, you have to have what's called a worker node, and you have to have a control plane. And they let you do this, and they say that's the basic install. And then afterwards, if you're going to do it in production, you would never do it that way because you have to undo a bunch of stuff. But you do that, it creates your little etsy file, right? I was double checking all my settings. Now when I save it and I check all of these different things, it gives me this little command that I can go run to finish installing Rancher. So now I've got my first worker node, which is my primary node that I'm on, and I'm all done. Is that it? Now I'm going to open. Oh, yeah, I got rid of one that was in there. I think that is the tail end of it. Yeah. So that was the basic install of Rancher, but that's just an empty module. So what does Rancher look like? Where do I have my Rancher? It's right here. So when I logged into Rancher, right, I get to the home page. Well, come on, Rancher, be friendly. Let me refresh my page. All right, global. So here's my global default view. If I want to go look at my SQL Server Rancher cluster, this is showing, right? I've got 10 containers out here deployed. I'm only using, I only have, 32 gigs of memory. So I'm only using 20% of my memory. I've got lots more space for pods over here. So you kind of see, you get this little dashboard of what you can do and how your little SQL Server cluster is running. That is what is in the system. Now let's go look at the default. And these are all the SQL Server containers that I deployed with Rancher. And you can see that I've got different images that I've been using in here. Let's go edit one of these and look and see what it looks like. So these are the 2019 CPT ones. And I've got my port names in here. And then I wanted to set up an AG, so I've got my AG ports that I've added in here. And then let's go look at our environment variables, right? So we gave it a host name, and then we gave it where we're going to be storing our data in there and our EULA. But then we also enabled the agent. We also enabled always on availability groups. We gave it a SQL volume and the password. And then if I want to make some changes, let's say, right? If I wanted to change something in here, what do I want to change? And I want to redeploy my container. It's just going to sit there and redeploy it, and that's pretty easy to run, and we'll just wait for it to spin down. It's not going to spin up the other container until this one is finished spinning up. It's not going to spin down the other one. So it's redeploying that workload in just a second. You can also come in here and set up namespaces. So that's what I did. I set up namespaces. And when I first started deploying these in here, they kept failing because I didn't have enough resources. So I created namespaces in here, and then I set limits for those namespaces. What would be how I want my SQL Server, how many resources do I want all of those deployed with? Do I want 2 cores? Do I want 8 megs of memory? Do I want 10 megs of memory? How much memory do I want? I set that all up in here. So that's under my workload section. let's see what else we got going on in here. Secrets, if you want to connect with secrets, those can also keep people on and off there. You can use that as a connection string as well, instead of regular passwords. If I want to start importing apps to use or images to use, this is where I'll start importing a lot of those in there. And then my members. Right now, I just have, these are the users that can do stuff. Let me go, sorry, this is the one I wanted. Default owner. Rancher cluster. Load balancing, this is what I'm going to show you. So as I want to start adding extra nodes in here, I can add extra points in here, right? So I've got my workload here, but as I want to start adding extra nodes, I would just go in there and it modifies that etcd file, and I just run a script on another Linux-based host that I've installed Docker on, and I get a node going on there. Don't ever do that on your primary, because it starts freaking out and installing lots and lots of SQL Server containers, because I did that. I thought it'd be fun. And then all of a sudden I was like, why is it whenever I try to deploy 1,000 are coming out? So something to be cautious of, but yes. So pretty easy to get around in once you're here. And if I want to create a new namespace, right, I would just come back here to here. If I can get out, go to global, right? And I can add another cluster, right? Which one was I wanting? And I can say this is my app developers cluster. And ideally, probably what a cluster would look like, because you control the access by cluster, a cluster would probably, that little profile would be each developer's work set, right? So they're going to have all of their web servers, their database servers and stuff that they're going to have in there. And that's custom. Right. You just finish filling this out, Windows support, Rancher, and you've got your little cluster. How much time do I got? Okay. So that is my Rancher cluster. And then on top of that, and you're going to have infrastructure people setting this up. This is where you're going to get into the fun stuff after you have your Rancher cluster set up. And let's go back to the PowerPoint. And I've got the next thing to show you, which is Ansible. So this is somebody doing this in Ansible, right? Whoop. So here's somebody creating a database in Ansible. They've got a database. They're putting some data into it. And then you can see what it looks like in Ansible and how easily that fits into. So this is my Ansel interface. Look, when we start modifying this one, I got an action that I'm going to refresh my dev database with a copy of production. But when you go in here to edit it, hold on, you'll see that what it is a YAML file. So a YAML file is when you look at back at the Rancher, and I'll slide that back in here. I'm going to pause this real quick so that you can see this and it makes a little bit more sense. When you go in here, and if you want to run these by hand, and I go back to my Rancher cluster, and I go to my default workloads back here. Let's look at this one. Let's edit one of these. Where's the view edit the YAML file? Hold on. You can see that I've got the YAML file going on in here. Right here. So this is what it has built that Kubernetes is running underneath, right? And you can come down here and you can see all of our options that we put in here in the database. This is also where you can cobble together several of those and add extra commands in here. This is where, if you're going to make this deployment, that in the YAML file, you would add the extra commands to like maybe do a clone. Or you could have, if you wanted to, which is I think what they're doing in this one, is that they have the Ansible utility running several steps. One of them is to run the cloning process, and the next part is to run the YAML file. Yeah, so there's the PowerShell module. It shows each of the different steps. Yeah.
Actually, that's probably what I was going to ask is, can you show more how to run Ansible?
I didn't know I could. I wanted to, but no, yes. Yes, but so Ansible's pretty easy to set up and play with. As you can see, it's pretty intuitive. And I think it's a lot, I've heard it's a lot, comparatively, it's a lot more intuitive than Jenkins if you've played with Jenkins. And I like Jenkins a lot. So we do a lot of coding where I work at when we're playing with stuff in Ansible. And so, yeah, it's just, yeah, sorry.
So how do you incorporate Ansible in your CI process? How do you consume it here? Because in your environment, how do you deploy it? How do you implement it for your constant deployment in your
So you would probably,
You're not using Rancher, right?
yeah, you would be using Rancher. It sits on top of Rancher. So that's what you've got, is you got your Docker engine, then you've got Rancher sitting here, which is doing the container orchestration, which is just spinning up and loading down the containers. Then you want to do the code deployments and all the extra things, right? The scripting that you're going to want to put on top of that. And that is where Ansible would sit on top of that. And it calls a YAML file down there to when it's deploying the container, right? So when you create those container clones here, when I showed you that YAML file, you would go insert that kind of command into the Ansible. Does that make sense? And then you would say with this, and then Ansible also has the ability to check code in and out so that you're deploying, right, whatever you've got checked into your repository that you want to check out. You can check out some code and generate it and then push it in Ansible. But you can do all the, and Ansible has a lot more kind of restrictions too, right? So each developer is going to have their own dashboard. They're only going to see what you want them to see within that Ansible. So, yeah, you'll have access, a lot of developers will have access only to their workloads to see what they want to see. So you set those workloads up, then you saw how you could easily quickly clone a workload. You can clone an existing workload, and then everybody's kind of containerized off. And there's tons of containers running around, but everybody has their own little pool to play in, right? Their own little like play yard that's got the fence around it that nobody else can get in to do stuff in. And so they can mess with their stuff as much as they want. Or you can just say, I'm sorry, all we're going to do is automate your deployments and whatever you do for code of the environments as well. It depends on how you want to do it. And then you are responsible for pushing code out there afterwards. But yeah, let me go back a little bit so you can kind of see what it looked like. Oh, come on. So here we've got our, right? Whoop. So here I am connecting. I've got my SSH password that I'm sending to the script right here to do the PowerShell. This is the part that's doing the database cloning and taking the snapshots. Then I got some set tasks that we're doing here to modify some things. I'm not sure what is going on in there. These are just like, some code generation that we might want to run afterwards, some kind of like after the fact script that we always want to make sure some security parameters are tied to. And then it's going to deploy, after it refreshes the storage, it's going to sit here and deploy the new YAML file.
You're still hard coding the serial. That's on the source. So
Yeah, that was on the volume that was showing that. So that was the serial number on the volume that we're cloning. So it was showing that hard-coded serial number on the volume that they were cloning. Yeah, that's in there. I say we were cloning. Anyway, so that's what's in there. And then we deployed it to the new container, all within that. All right. So that was that one. And then hybrid cloud. So let me show you the hybrid cloud demo. I'll wrap up a few minutes early, and then we'll do some Q&A. So the cool thing, what we were talking about earlier, is that people are able to, and I am going to see, it's a funky-looking environment. So let me make sure that, all right, I'm going to disconnect. So my environment's really kind of weird looking because I'm connected to a server internally. And only one of our machines actually has Azure had the TCP/IP pipe open through the firewall to get to the Azure machine. So this is my database environment here. And I'm going to do it slightly differently because I think this is kind of cool. So what I was going to do was have one of you guys call out a value and whatever. I was going to say, hey, well, let's do this. That's not what I wanted to do. I was going to create a new table because we have somebody from Chewy here. Here. And then show you what I've got going on here. So I've now got the table in here, right, called Chewy in my Summit DB. And what I've done is set up its volume right here. So this is what I call a protection group, and this is my Summit protection group. And I've got this volume right here, which is sitting in my Mountain View array, replicating up to this array, which is sitting up in Azure. It is actually sitting up in the Azure cloud. And then once I have all of that going, and I've got data, so this would be a good simulation of I've got a production data set, right? And I want to take something up to my cloud environment and do some development on it. So what would I do? And I'm going to do this so that you guys know that I actually really did do this. Hold on. Come on. We're going to put a file in here because my Azure VM is like the smallest VM of all time. It really has like no memory, and it crashed hard today. So once I've got all that in here, what you get to do is come around. You can see I'm replicating that up to Azure, right? And it's replicating, if we look at this, I'm replicating it every 5 minutes. So I'm going to go connect to my Azure VM. This is the only machine. It's the Nesta machine, so I had to change everybody's background so I knew what was actually going on. That's why this one's popped out. So now I've put that data up in here to Azure. And the idea would be that I would spin up an awesome container in Azure. So we'll walk through what we were doing in the script. So what I'm going to do is go grab my production data and say move it up from my Mountain View office to my Azure cloud environment. So I'm going to run that part. And then I'm going to overwrite my volume. Sorry, I told it to sleep for a few seconds because it does take a second to replicate, and if I ran it all immediately, you wouldn't see the data up there. And then I'm going to overwrite my volume that's sitting up here in Azure. And then the idea was to do this lovely thing. Why did I do that? That works fine. Was to do this and spin up a container. And this worked up until like about an hour and a half ago. Actually, it was earlier than that. I tried so hard, and it broke early this morning when I was running through everything. My Docker environment, which has been up and running, you can see it's right here. It keeps coming up momentarily and then crashing, and I uninstalled everything and reinstalled it and was waiting for this little bad boy to, we'll see if we can get it up. But it kept crashing this morning, and I was like, every time I would run ps-a, nothing. So when I do this, it doesn't like me. Yeah. But if you look over here on this cloud, this Azure VM, and I go over here to my container thing, let's run that command again. And look, and refresh. Container. Oh, nobody's being my friend this morning. All right. We're going to give it a second, and I'm going to look. It's being a little slow. And see if we've got our data up in here now. Oh, there it is. There it is, Chewy up the top. Yeah, so that replicated over from the cloud. And I would mount it up in my container. I would have done an AG, but I didn't have enough resources to keep the AG up and running too. That's the other way you can move data to. If you want to do asynchronous AGs between on-prem and in the cloud, you can also set up an AG. And that was it. Do you guys have any questions? Finished up a little bit early? Yes.
I have some questions around, so like the VM, you put it on your DNS, all that stuff. How, like,
That is the question, right?
right? I mean, how do you replicate all that security?
So I was going to talk about that. So thank you. I meant to talk about that. That is the thing with every kind of DR plan that you do, no matter what, that I think is the trickiest part, is getting all the security up. So you would have to, and that's what I couldn't demonstrate because we have not gotten that set up in our lab yet. You do have to set up a DNS server that you are replicating those kind of settings. So some people, if they're replicating their entire VM up there, they have it replicating at a set amount of time a day, where they're maybe once a day or a couple times a day. But you do have to extend your network into Azure to have that cross-hybrid cloud.
I understand that.
Yeah.
The actual container itself, like if I, like say, I have my database name Will, right? Or my SQL Server, right?
Yeah.
And I move that to, a Docker, or I give it multiple Dockers. How is the DNS going to resolve?
Oh, so Docker within itself has a DNS because everything is running off these multiple port numbers, and I don't have that set up in my lab. That was I tried. I'm like, that is not me. That is outside of my skill set, but it has a DNS server that sits in it that communicates, so that not only, so you would have to replicate your general network out there, right? But it also, that is where I was trying to say earlier when I had that SQL 01 name and I was showing it, when the DNS server is running within the container orchestration, which would be Kubernetes or Rancher or OpenShift, it is then communicating with everybody outside that SQL 01 is sitting here. So it can move around servers, because right now it's tied to my IP address, so that DNS is getting updated as they move that container around from different servers. Does that make sense? So it's got it has to have a unique port number within the environment. So
Managed instances,
huh?
so we use a lot of managed instances, so
Yeah.
we don't have that port problem because you get a port assigned dynamically.
Right.
to the managed instance.
Right, to prevent you from probably having that contention issue, or think about it. But yeah, they will bark at you when I go to try to reuse a port and put one in there. As soon as I put it into the Rancher, and if I forget to update it, it barks at me before it even deploys it and says that port number is already in use, and it won't let me deploy it. So, but yeah, it's the internal DNS to Rancher or whatever container orchestration that you're using that will publish where that is for everybody. Yes.
I saw that you went to one place and went to another place to see if it had replicated.
Yes.
Would you be able to put a monitoring system where you would be able to see that replication?
Yes, we actually there is a monitoring system in place so that you can see the replication between them. Yes, so usually it's every 5 minutes that it's going to get, and I was trying to do it when I was doing it this morning because it was such a small data set. It was able to, but I think the traffic was lower. It was able to do it in like just a millisecond to get over there. So I put a 10-second wait in there and thought it would be like great, but yes, you can put replication in there to see. And when I take those two, when I was applying that, it told me what time frame that snapshot was taken in. I was just trying to get the most recent one. So I was waiting for that very last one to get in there. But that it's part of that name is it has the timestamp of when that snapshot was last replicated in there. So it has that name in there. Yeah.
So I'm missing something when provisioning the storage. So let's say an example of a container or just a regular VM, and taking snapshots and provisioning to 10, 20, 50 development environments from the image, from another snapshot or another container. The trick here is that the database, you want to mount them to their own directories, their own mount points, and so forth. Automating that process has been a little bit tricky because you got to go through, the web page to get the serial number of ID, or do git disk, get the volume of the ID, then match them, and it's a manual process. And if you want to do this, you know, if we want to do like 30, 50 of them, or provide the power to the developer to do it themselves whenever they want, you know, how
So
can we do it? Because what we have to do is pre-seed the serial numbers of the destination.
yeah.
and the
So
scripts.
if you're going to be doing the cloning, you're going to want to have more dedicated, like a little. So there are a couple things. One, everybody's standardizing what's called container storage integration. So it's the CSI plugin. So everybody's coming out with that right now. So all vendors will be using the same API calls, no matter who they are. So that's integrating in with storage, but it's not quite as fancy, right? So that's kind of bare bones. That's just giving you the volume being attached to your container. So that's what you're going to be able to do with the CSI plugin. So that's what that does. And then after that is done, then what I would probably suggest that you do is use something like the orchestration tools, like ours is called Pure Service Orchestrator, that integrates in, that allows you to import a clone. Or you don't even have to do that if you don't want to. If you had a standard like gold copy clone name, right, then you can overwrite all of those, because then once you've got them mounted, right, into there, I'm trying to think. Yeah, you still have to have the serial number, don't you? Yeah.
So right now, deployed all those images from the gold copy. However, refreshing the storage or the mount points for specific databases on each.
Yeah, you have to have the serial number.
But I have to have the serial number hard-coded on each of the scripts.
I am sure Simon Dodsley and John Owings have a more automated fashion of doing that, and they're working on that. So ping me afterwards, because I know they're automating more and more of that, because containers are coming up so much that there are teams of people working on features that people are asking for all the time. I know that we're building more integration than lots of other people are too into the application layer, so that it's more of an application call, like a SQL Server call that you're going to make, and that you don't have to worry about as much. We want to get further into the application layer. So I know we can do the VSS snapshots as well with the plugins. We've tested that with the containers, and that works, and that's kind of cool, because you can't do a lot with. Have you ever tried to do VSS snapshots with virtualized environments? Depending on how they're set up, they don't work so well. But because you've kind of taken that hypervisor out of there, they work with containers. So that's kind of interesting. But I think it has to be I haven't tested on Linux, I know that, but we've tested on a Windows-based container. Any other questions? Yes?
So can you explain again just how those microservices work? So they just instantaneously spin up a container and then it goes away?
Yeah, so they're usually, what you saw with me do was the -d, detach, which is a stateful container. It's going to stay up and running. But let's say you've got something that, I'm trying to think, welcome letters, right? So I worked for somebody who did back in service for almost all the cell phone providers. And we had this big process that kicked off once a day. All new, like if you joined AT&T or Verizon, you got a welcome letter. Welcome about, here's your insurance. So that would be a microservice, right? That's going to spin up, do it, send the welcome letters, and spin down, because that doesn't need to be sit there running all day long. It just needs to do its one job when you need it and go away, and that would be a microservice. So those are less stateful type things. But that's really nice that they're no longer attached to the underlying hardware, right? Because you would think about like trying to schedule maintenance windows for different things, and you might have to exclude things because of what's happening at that time. You're completely detaching that little service from any kind of underlying infrastructure, because it's now got a whole cluster to run on. What else could be a microservice? I almost thought about that. We were talking about, and we've done this, something, if you were to look at a less stateful container, I think that something that would be really interesting to put in containers are things like ETL jobs or things like that, our jobs that send things. So we have those servers that don't use resources all day long, but they have a one job that they do, but they need to be really heavy while they do that. That could be a good use of a container, because you don't want it sitting around all the time. But when it needs to be up, it needs to have a lot of resources. Yeah?
Just a comment. When we look at containers and what it boils down to us in terms of why to do that, certain errors from runtime to build time.
Yes, exactly.
For hour and a half, you do it all at the build time, and then you spin it up, and it's all there. And in our case, we deploy certain things like hundreds of times, and our SLA around success of the deployment just couldn't get high enough. There's the physics of scalability just doesn't work. And the only way to get to like 4 nines is to move to container architecture altogether.
Yeah.
And avoid all this kind of lengthy, procedural, kind of incremental installation scripts that always tend to fail somewhere.
Especially when you talk about branching of code, right? Because UAT environments and QA environments, you want to have a merged where multiple people are pushing, but what you run into, how many of you guys work in agile shops? So, right, this is the branching issue, right? You've got a feature coming, you're supposed to go first, your feature somehow is not working, but everybody else has coded off that feature in the legacy world, and now we're all stuck behind you while you're picking on you, right? While you're working because we've now got your code branched in. But if everybody has their own copy of what production looks like and it's really up to date, it gives you a little bit more flexibility of who's going first for them to update their code and fix those issues. And for us, even just getting it not where it was every day drastically improved our code quality by being able to push those production sets down closer. And we couldn't get a copy to every developer. But we still had lots of issues going into dev where their code was like, did you even look at this? Did you take it, right?
And it's much faster as well. Instead of spending hours and hours to set up the right environments and everything, you spin on those containers in no time. And it's, as you pointed out, really close to production environment. So everything moves faster.
Yeah, your junior dev, when he like pushes that really bad code and wipes out the entire dev environment, it's okay because it was just him, right? The funniest thing I've ever seen, everybody works with somebody who's a jerk, right? So our Java architect, not a nice guy, we didn't like him at one of my jobs, and he had the young college intern who also nobody liked because he never did anything. And so the Java architect was in charge of checking his code out and making sure all he was doing was writing a cleanup job for a bunch of files that were sitting in a container. So the Java architect took it and put it in his environment that he had been working on this key project on. Do you know, because it was a Linux environment, what the young guy did? He put a rm-rf star to go from the container that it was in on down and wipe everything. And the architect put it in the root directory of his machine to test the code. And all he did was sit there and go, oh God, oh God, oh God. And we're like, yeah, the intern was not going to last much longer, but we're keeping around for that. But yeah, the sad thing was that he actually, we had to rebuild that environment, right? It had to go back to tape, rebuild the environment. It affected our production employments by a week. So those kind of things you negate when somebody does a really bad code push that's going to affect the, everybody else early on. You're going to catch those. I had a vendor who gave us code to push, and luckily we walked through it. But I couldn't believe it. It was supposed to be an update, and their update was drop and recreate all tables. Yeah, and I was like, that's not going to work. And we didn't run it. But yeah, you're gonna stop. How many of you guys have read? I was going to say this because I tell these stories all the time, and everybody asks me, "Did you work at the Phoenix Project Company?" How many of you guys have read the Phoenix Project book? Anybody? If you work at CI/CD, it's really kind of an interesting book you should read. It's 3 guys that work for big tech companies, and they're talking about the realizations that they come to the process. And I'm reading the book, and I'm like, I didn't have a wise Buddha sitting on my shoulder giving me all this advice. We just kind of, everything they're talking about in the book, we've done in our companies. I think we all who are good have kind of started doing that. But it was just, we kind of came to it through trial and error and saying things didn't work, right? We started limiting our change control windows and trying to figure out what our bottlenecks, and that's what this is how do you get better at what you do? And you go find your biggest busy bottleneck and you target that first. But it's a very interesting read. So thank you guys for attending.